This is geometry, section 2.4, deductive reasoning. So, we've learned about one type of reasoning in geometry so far, and that was inductive reasoning. The other type we're learning about right now is deductive reasoning. Two types of reasoning we use in geometry. So, inductive reasoning is basically patterns and guesses, like we talked about in the first section. Deductive reasoning is basically using logic. So, we're going to use some shortcuts to decrease the amount of writing we have to do. We've been doing a lot of writing in this chapter so far. So, we're going to use some symbols. So, we've talked about negation before. So, negation means the opposite of something or not an event, or an event does not happen. So, to symbolize that, we're going to do a little squiggle and then A. This means not A. If we have a conditional statement, if A, then B, to symbolize that, we're going to draw A, and then an arrow, and then B. So this right here means if A, then B. If we have this conditional statement, if A, then B, the converse would be if B, then A. So to symbolize that, B, arrow, A. If B, then A. The inverse is when we negate, so if not A, then not B. So to symbolize that, not A, then not B. Contrapositive, switch and negate, so if not B, then not A, not B, then not A. The biconditional is A, if and only if B. So to symbolize that, we're going to draw a double arrow. So A, if and only if B. That's what that symbolizes. So an example, let A be the event it is raining, and let B be the event the game is canceled. So write these out in words using the symbols we just talked about. So B, arrow A would mean if B, then A. Well, B is the game is canceled, so if the game is canceled, then A, it is raining. If B, then A. Second one, if not A, then not B. So if not raining, then the game is not going to be canceled. This right here, the double arrow, means if and only if. So remember, we don't write the if at the beginning. So this would be it is raining if and only if, remember capital IFF means if and only if, the game is canceled. So, deductive reasoning. What is deductive reasoning? There are two laws we use that are part of deductive reasoning. One is called the law of detachment. One is called the law of syllogism. So, first, the law of detachment. Law of detachment says we've got a conditional statement. If A, then B. Then, second step is the hypothesis of the conditional statement happens. Our conclusion, this three dots right here means therefore. Therefore. So, if A, then B, A happened, therefore B happened. So, what do I mean by that? Law of detachment starts with a conditional, as I said. Starts with a conditional, repeats the hypothesis. So, the hypothesis, first part of it, happens, and the conclusion becomes true. So, what does this mean? Well, if we've got the conditional statement, if it snows, then I'll go to the gym. Then we say, it snowed on November 11th. Well, the first part said, if it snows, then I'll go to the gym. So if it snowed on November 11th, then I went to the gym on November 11th. So symbolically, this would be, if it snows, then I go to the gym. It snowed on November 11th. Therefore, I went to the gym on November 11th. Another example, if right angles, then congruent angles. So this means if you've got two right angles, then those are congruent angles, because obviously two right angles are congruent to each other. So If right angles, then congruent angles. Angle P and angle W are right angles. Our conclusion would be angle P is congruent to angle W. It says if they're right angles, then they're congruent angles. P and W are right angles, therefore P and W are congruent. Symbolically, right angles means congruent angles. P and W are right. Conclusion is P congruent to W. Alright, show that the law of detachment cannot be used to arrive at a valid conclusion in these situations. So, conditional statement says, if it's Labor Day, then it's a Monday. Labor Day is always on a Monday, so if it's Labor Day, then it's Monday. Second says, February 7th, 2011 is a Monday. We cannot conclude that February 7th, 2011 is Labor Day. The law of detachment does not go backwards. So, in order for law of detachment to work, we have to say that the first part happened, not the second part. Because as we all know, February 7th is never going to be Labor Day. So this is no conclusion. We cannot conclude anything from the conclusion of the original statement. We can only conclude something from the hypothesis. Don't worry about the symbols. So, if a shape is a square, then the shape has 4 sides. This shape has 4 sides. Is the shape that I'm talking about a square? Well, not necessarily. I can draw a 4-sided shape that's not a square. So just because it says if a shape is a square, then the shape has 4 sides, doesn't mean that this goes the opposite way. So because I say this shape has 4 sides, does not mean I can conclude that it's a square. No conclusion. Again, don't worry about the symbols because we did not have a conclusion. So the second law, law of syllogism. The law of syllogism we also call the cut out the middleman law. So, law of syllogism is basically 2 conditional statements put together that turn into 1 conditional statement. So, if A happens, then B happens. If B happens, then C happens. Therefore, if A happens, then C is eventually going to happen. So, law of syllogism starts with a conditional, adds another conditional, and uses transitivity. We'll talk a little bit more about that in the next section. Uses transitivity to create another conditional statement. So, for example, if it's cold, then I'll go to the mall. If I go to the mall, then I'll buy a video game. Therefore, my conclusion could be, if it's cold, then I'll buy a video game. Okay? I've got, if it's cold, then I'll go to the mall. But if I go to the mall, then I'll buy a video game. So if it's cold, eventually I'm going to buy a video game. So if we let cold be event A, mall be event B, video game be event C, we've got if A happens, then B happens, B happens, and C happens. Therefore, if A happens, then C is eventually going to happen. Last example, if the fridge doesn't work, then the food will spoil. If the power is cut, then the fridge doesn't work. We've got to be careful here. Notice how the conclusion of this statement doesn't match up with the hypothesis of this statement. But if we switch the order of this, we've got the conclusion of this statement matching up with the hypothesis of the first statement. Therefore, if the power is cut, the fridge is going to stop working. But the first statement says if the fridge stops working, then the food will spoil. So the part that I'm going to cut out is this part, the fridge not working. Because if the power is cut, then that's going to happen. The fridge isn't going to work. If the fridge doesn't work, then the food will spoil. So my conclusion, or my third conditional that I'm going to write, is if the power is cut, then the food will spoil. So if I say fridge not working is F, food spoiling is S, power cut is P. Symbolically, this would be if F, then S. If P, then this would be F. P, then F. So we cut out this part, and we end up with this part. If P, then S.